In 3.4, we're going to be looking at intermolecular forces. These are not to be confused with the forces that we've talked about before, which are intramolecular forces. These are the forces that act within a molecule, for example, ionic, covalent, and metallic bonding. Intermolecular forces are forces that act between stable molecules. Differences in physical properties are the direct result of intermolecular forces. In fact, intermolecular forces are crucial in chemistry for several reasons. Number one, they determine the physical properties of substances such as boiling and melting points, vapor pressure, and viscosity. These forces influence whether a substance exists as a solid, liquid, or a gas at a specific temperature or pressure. Intermolecular forces play a key role in solubility. Intermolecular forces are important in biological processes. In biological systems, intermolecular forces are essential for the structure and function of biomolecules. And in chemical reactions, they can affect the rate and outcome of chemical reactions. We're going to look at different types of intermolecular forces. The first type is called dipole-dipole forces. Dipole-dipole forces are attractions between opposite charges. They exist in polar molecules, they're relatively strong, and they occur between all polar molecules. The more polar a substance is, the stronger the dipole-dipole forces. Here we have a polar molecule, HCl, and there are dipole-dipole forces between the slightly positive charge of one end of the molecule and the slightly negative charge. We have two examples here between hydrogen and chlorine, between two HCl molecules. The dipole-dipole forces exist. And here's another one between hydrogen bromide, where there's a dipole-dipole force between these two polar ends oppositely charged. The second type of intermolecular force is the London dispersion force. It's a weak attractive force acting between all entities, including all nonpolar molecules and unbonded electrons, caused by the temporary imbalance of electrons within entities. These forces are very weak. The reason why hydrogen gas and fluorine gas have very low boiling points. In this example, this table shows the increased strength of London forces. And as strength increases, so do the boiling points, melting points of the molecules. And there's a correlation between the increasing strength of London forces and the number of electrons per molecule. So as the number of electrons per molecule increase, so do the London forces. So London forces account for why some substances are gases at room temperature. They exist between all molecules, even in polar molecules, but London dispersion forces are insignificant compared to dipole-dipole forces. And they only happen when molecules are close together. The farther apart the molecules are, the less the force of attraction. Van der Waals forces are the weak forces of attraction between molecules, including dipole-dipole forces and London dispersion forces. Next, we'll look at hydrogen bonding. Hydrogen bonding is very important, not only in chemical reactions, but especially in biological processes. These are the strongest intermolecular forces, 4 times stronger than the dipole-dipole forces. A strong type of dipole force of attraction that occurs only in specific types of bonds between nitrogen, oxygen, fluorine, and hydrogen. So here we have oxygen and hydrogen, and in between molecules of water, there are hydrogen bonds. These hydrogen bonds can also form between molecules that form between nitrogen and hydrogen. And if you notice, they're always taking place between the molecules from the slightly positively charged hydrogen atoms and the slightly negatively charged nitrogen atoms, or oxygen atoms in this case. These also occur, as we mentioned, between fluorine and hydrogen, Why do hydrogen bonds occur? They occur because of the large differences in electronegativity and the small size of the hydrogen atom, which means the positive pole in a hydrogen atom is highly concentrated and strongly attracts the negative pole of a nearby molecule. Let's take a look at this summary of intermolecular forces. The strongest forces are the intramolecular forces. These are the bonding forces between atoms. But the intermolecular forces, the weakest are the London dispersion and the hydrogen bonds are the strongest. And remember, we said they are 4 times stronger than the dipole-dipole forces that exist. Please read section 3.4 and complete homework questions assigned.